Doug, for chairing the first part of this session. We'll move on to the next. My name is Koen Zubier. I'm from KWR, Water Cycle Research Institute in the Netherlands, and I lead the collaboration we do on the field of MAR in Allied Waters. Today we have a session on urban MAR. I think the topics has shifted a bit. But anyhow, I'm very happy that we have two great speakers who will entertain us for about the next hour. First speaker is Dr. Declan Page from CSIRO in Australia. And he, together with quite a large team of experts and consultants, I think, made an inventory of managed aquifer recharge for strategic storage in the north of Australia. That's something different from the south this time. So, floor is yours, Declan.
Thank you. I'll try to take a long time.
You can.
Yeah, I will. Hang on. Okay. Thank you, everybody. Thanks for coming. I'd like to thank especially the first author, Anthony Napton. It's actually mostly his work. It's about modelling. So he did most of the work. Today I'm going to talk about MAR in Darwin and the Northern Territory. Don't know if many people have been to Darwin or Australia in general. Australia is often called the driest continent in the world, but if you go to the north, it can rain a lot around there. You can see a picture here of the Darwin rural area, so it's not even really quite urban, so sorry about that. So this is sort of the suburban fringe you'd see around the city of Darwin. And Darwin is the capital of the Northern Territory, which is our least populated sort of state territory in Australia. It's got about 250,000 people all up, and Darwin's only got 100,000 people. And about 8,000 people live around the edge, and they live in little blocks like this. And you can see this is in the dry season. And even though it rains about 1,800 millimetres a year. You'd think wouldn't be much of a problem there. There's not anyone lives there. Yet still, it all rains within about 2 months, and then it dries out. And so, even in a place where no one lives and there's not really much industry and you wouldn't think much water use, they have a water shortage problem. It's partly probably their own fault because they're also the highest water users in all of Australia. They use about 1,800 litres per household per year. So they love to throw water around. They like to think it's tropical, and they like to water all their lawns. They also like to grow mangoes. Anyway, so we were asked, they were starting to run out of water, and we were asked to look at is managed aquifer recharge feasible to, raise the water table in a precinct sort of scale kind of thing. So I've said that it's 1,700 millimetres of rainfall a year. Oh, the other reason is I'll go back to the picture. It's more interesting than writing. The other thing is all these people rely on their bores for drinking water as well as all of their water. There's no reticulated water supply around here, so if their bores run dry, they actually run out of water to drink, and makes these blocks pretty hard to live on. They're hard to live on anyway. So it becomes quite critical, and obviously the people become quite upset if the water level goes too low. So I forgot to mention this. This is a small part of a larger government initiative called the Northern Australia Water Resource Assessment, and we looked at the technical feasibility of managed aquifer recharge to mitigate declining groundwater levels. Now that was a big project. Probably about every couple of years, every 5-10 years or so, the Australian government has a big push. We're going to open up the north, because no one lives there, and it's thought to unlock the potential. And this was another big push to see if we can get more people to live there, get a bit more productivity going on out there. So this is a photo on the side of the road from the Darwin Rural Groundwatch Association, and you can see their if laser does work. No, it doesn't work. You can see they have you can see they monitor their groundwater levels. The local Department of Water does that there. And you can see it track down over the year, and people get quite active, and it's quite a topic of conversation for everybody around there. Because of course, if they run out of water, they're all in trouble. So what we've got here is two graphs of declining groundwater levels after a series of poor monsoons. So it goes back to the first graph, one on the top, back to 1997, and the one on the bottom to 1985. They're just two bores from the region. There's nothing particularly special about it. It's a dolomite aquifer, and it's what people call a fill and spill system. So every year she fills up, and then it just basically drains out and spills over. So initially a lot of people say, look, there's no point doing MAR in these sort of systems, because basically you put the water in, jump, and it falls out. You can see here the various, they've got the rainfall plots, and you've got a bore level going, well, on the top, it's the blue circles. And the bottom one, we've also got one for what's called Howard Springs. Now, Howard Springs is a groundwater-dependent ecosystem. It's very important to local Indigenous population. And you can see the no-flow level down there. And at around about 2005, we started to get dangerously close to the no-flow level. That's where the springs start to stop flowing, and I guess it becomes a concern for the health of these sort of isolated groundwater-dependent ecosystems. So they've had a particularly bad year this year, and you can see it's probably represented better in the bottom graph, but the decline in the height of the bore, which are the light blue dots, I would point to them, but I can't, over a successive of 3 years. And you get three bad monsoons in a row, and people start getting a bit upset. They start worrying about it. So, for those of you who are into modelling, here's the bare minimum amount of information that I could probably make sense of. It's a mod flow model and the Kulpina Dolostone. So we looked at two things in it, and look, I'll have a paper and if people want to look at the paper and the full details of modelling, I'm happy to share that and give you my details later on and pass it on to Anthony Napkin. We looked at augmenting seasonally declining groundwater levels in private water bores during the dry season. So looking at, do you do this by well injection or do you do this by infiltration? Because they both have their differences. And we also looked at what is the potential to actually provide a longer term storage for Darwin, like to have like a strategic water storage. Some people might have seen the talks previously, like for Liwa in, I think it's Abu Dhabi, and there's a couple other famous towns around the world where they're now investing in a strategic storage to actually to take water during this monsoon season when it is raining every day, and store that water and take it out in times, of course, when it's a bit drier. So this is the area we're talking about. You can see the model area domain which is what the red line is. And because this is sort of an exploratory study, we put together 5 different MAR schemes. They're just the ones down the bottom there. You can see, really I wish I had a pointer, I could really drag this out for a bit longer, but you can see Darwin out on the peninsula on the left, and then you've got a highway and in this area down there is what's called the Darwin rural area, like the picture I showed before. And you've got a highway going down south for thousands of kilometres to get to Ayers Rock. Not many people live there. It's pretty wild country. It's pretty hard living there itself. Anyway, so we got the 5. We set up 5 sort of, I guess, you could say what we might say typical MAR schemes around there. You also got a series of dark blue and light blue dots up in the north of the map. We also looked at the potential to strategically store water in the aquifer there. And so we've got both injection and recovery wells there, and looking at sort of in that part of the aquifer is actually confined, whereas in the bottom lower section it's unconfined. And so in the confined section there was still available space. So it seemed like an awesome place to maybe set up a strategic storage for the city of Darwin. So this is one of those flea flow maps that they produce. I always find them pretty hard to read, I must say. Like you look at the lines and they almost look the same. So I'm not going to dwell on this map. What I'm actually going to draw your attention to is MAR 1 and MAR 3, and they have a line across them. And I'm going to show a cross-section of that line because I find these maps really difficult to read. So the next slide is going to be a cross-section of those 2 MAR schemes, and I'm going to explain which is basically the results of the modelling. Okay, so MAR 1, which is the one on the left. Got quite a few injection wells there. So what we've got here, I'll go through what the lines mean and I'll explain the results. Going from the top down, or not quite, but maybe the top, the green is the surface groundwater, the ground surface, and the red is what the model would predict without MAR, and you can see it's quite low. Same goes for the bottom one as well, and they're both the same really, but they're different locations and have I guess a different variability in terms of how they react. Now you've got three lines in the middle. You've got the light blue one and the dark blue one. I'll talk about those first. Now these are well injections. So this is the idea that you just put some injection wells, punctuate them around the area, and just start injecting water in there. So we looked at two different scenarios. First one would be early injection. So the thing about Darwin is when it's wet, it's really wet. When it's dry, and there's not a lot of water available in between. So first we looked at if you just started to inject as soon as the rain stopped. As soon as the rain stopped, you just start injecting, because the people keep using water anyway. And the other one was injecting based on a trigger. So when the water gets to a certain level, boom, then we start to inject, depending on how people use water. And you can see it's obviously a difference. There's probably a couple of extra months of punching water into the underground to try to get that difference. And you can see in both graphs, top and bottom, A and B, what's that, about a 5 metre difference, well maybe even 10 metre difference in what you can get. The other one, the yellow line, I'll draw your attention to, is actually looking at infiltration basins. So they were actually probably the most favourable in terms of efficiency, how much water you get in compared to how much water effect on groundwater rise. And they're also cheaper, of course, as well, cheaper to run. The problem is in this area, and I think we've heard before, to put in infiltration basins in, you need quite a few hectares of them. So we looked at infiltration rates are pretty poor around there, kind of thing. So we don't have the sort of metre per day, 10 metres per day I've seen for other SAT schemes here. You need about 130 hectares of infiltration basins, which frankly wouldn't be possible in this environment because it's all the blocks already taken. It'd be pretty hard to do that. So although that's the most efficient way of doing things, you'd probably have to do it by injection bores, which depending on how you want to do and how much water you're willing to stick into the underground, you'd either trigger it based on a trigger level, which is the dark blue line, or you start injecting as soon as there's room available in the aquifer. So you can raise the head by about 10 to 15 metres. And that would probably be enough to save the water supply for the people living there, because the bores aren't that deep, as you can see. They're only, 20 metres below ground. So they're only pretty shallow. It would be reasonably easy to fix. The other thing we looked at, I mentioned before, which was a side thing, which we weren't asked to look at, but I found it a lot more, I guess, promising than doing this, was looking at a 5 gigalitre. Now, don't use gigalitres here, not so much, but it's an Australian term we use a lot, which is 5 million metres cubic a year. Pretty big, a reasonable sized site. Could you actually, and it seemed to be viable to actually store this amount of water and recover it each year over there anyway. It's a freshwater aquifer, so you want to be pretty careful about the sort of quality of water you put in there. But given that this is the same sort of river water that's coming naturally from the landscape, I think it can be done. You could take it from places like Darwin River Dam, which is the water supply. It makes the water utility a bit nervous if you start taking water from their main water supply in the middle of summer. But it's a lot less than will be used during evaporation. I guess, in the end, there is an opportunity here for strategic water supply to the north of Darwin. It's an area that's not used for anything at the moment. It's a wildlife reserve, and so in that sense, could be the ideal place to have a strategic storage for Darwin's future water supply. Or, they could just get a reverse osmosis scheme or something, like many other cities do in Australia. Up to them. Well, that's it. I'm finished.
Thank you, Declan.
Thank you. Went 14 minutes. That's
Well
all right.
done. Are there any questions from the audience?
I welcome many questions.
Are there many questions from the audience?
Boris, my co-chair for the next session. Please, everyone come to health as a session up there later on.
Yeah.
We're worried you don't want to come.
Thanks. You said the aquifer, where the water is stored into, that it drains very quickly. Every year it more or less drains naturally.
You
Did-
reload
Can
it.
we,
I'll show you
bring
the
back the
picture.
presentation?
Was the model used to calculate how much of the water that you recharge is lost, or depends it on how well
Yeah.
you use it, abstract it again?
Yes, it was. And if I can get the
Could we bring back
presentation, too quick on that.
crew in the back?
Can you put the presentation back? Thank you. Perfect. That's what I wanted.
Right there.
Yeah, it's a dolomite, so it drains really quickly. It's got and the northern part of the map, it's got a clay layer and aquitard. Gets punched through. So normally, as I said, it's a fill and spill, so people don't think MAR will work. I don't know if I had the efficiencies of the system here. It is actually worked out in the paper, and that's how I know that the infiltration basins were the most efficient as well. I didn't write it in here. Didn't think anyone would ask me that question. I can show you. I can show you any time, Boris. I'll give you my card, and we can. It was worked out. In fact, it was one of the criteria is to look at how much water is basically just goes to the side and is wasted compared to how much actually goes to moving up the groundwater level. I don't have the number in my head, but I can get it for you.
And the water is wasted to rivers, natural rivers, or along the coast? Where is it flowing to? Do you know when it drains naturally?
Yeah. Well, this is the map here. You can see, and again, I wish I could. Oh, here's another pointer. How about that?
It doesn't work.
Doesn't work either. You sure? I reckon it works. There's a green one. Yeah, it works, man. Look at that. There's what's called the Howard River here, and it kind of all basically drains into the ocean of various sorts. There are a number of different aquifers there, and some of them also have a bit of saltwater intrusion, depending on how much you pump, but they all basically drain towards the sea. No problem.
Any more questions? Otherwise, I have a question, Declan.
Oh, good.
I think now they take the water for free from that aquifer.
Yep.
Who will pay for such a future MAR system? Are there any ideas on how that should be done?
My general view is the person who benefits should pay. However, in this case, yes, the water is free. They have a water right because the local water utility doesn't send water there. So there's always a bit of people like to live in places like this. They're usually pretty independent, you know, and so they don't like people really telling them, you know, you have to start paying for their water. There'd probably be really simple ways you could actually manage the water better, like you could use metering, you could repair the bores, you could invest in water conservation. But all these behavioural changes are a lot harder, even though they're a lot cheaper to actually implement. So they always like to look at really complicated technical solutions for what should be a lot easier way to do it. If you can imagine, these people will have sprinklers all overhead, they just go all summer. We could go that way, but of course behaviour change is much harder to affect than these sort of things. So they wanted to look at that. I guess for me the shining light was, though, the opportunity for strategic storage for Darwin.
It's the start. Yeah.
I don't know who'll pay. That's another chapter.
Thank you.
Thank you.
One more question?
Go ahead.
Evaporation rate.
Yeah, good question. Good question. It'd be really high kind of thing. I don't know. Again, I don't have it in my head how high they are. I'm not even sure. I'd have to even check if it's actually in the model. Yeah. How much it goes down? That's a good question, Peter. I don't know offhand. I'd have to look back at the guys' calculations to see how they are. But yeah, it's really high. It's really high there all year. I mean, especially in the dry.
To share your card.
I'd like to think it was factored in. Yeah. Thank you.
Okay. Thank you, Declan.
No worries. Thank you.